Okay, this is 11E. This is our very last section. I think there'll probably be 3 videos in this section, so we are getting so close to the end. I know you're so sad. So in this section, we're actually going to talk about solving rational equations. In 10, we solved radical equations. And we're going to use some of the same ideas in solving equations, these equations, as we did in the last unit. So we need the LCD, but now we have an equal sign because these are equations. So this LCD has to be applied to both sides of the equal sign. And when we do apply the LCD, our fraction goes away. We have no more denominators. And this is very different than solving rational expressions, because expressions, when you multiply through like we've just done in 11D by the lowest common denominator, you don't get rid of your fractions. You get a single fraction bar and you work to simplify them. This looks different. So, and then we're going to, once we get rid of the fractions, we're going to decide if we have an x squared term, we're going to set it equal to 0 and solve by factoring. If we only have an x to the first, a single x exponent, we're going to isolate the x and solve by itself. So I'm going to leave example 1A. I'm going to start on B. I probably will put 1 on the video check. So I'm going to skip over here. So I am looking for the lowest common denominator between all 3 denominators that I see. Here are my 3 denominators. So my numeric portion is going to be 12, of course, and then I need a base of x and to the first power. So 12x is going to be my common denominator, and I am going to write it like this. Those of you that had me last year, we cleared fractions when we were solving equations, and we wrote it like this. And then you say, this is how you get rid of your fraction. You say 12 divides into 12x. The 12s cancel, leaving me with x to multiply times this numerator 5. 5x is what I'm left with there. No denominator. It's gone. This 12 canceled into this 12. Minus 2 goes into 12 6 times. The x's cancel, so you have 6 times 1, which is just 6. This denominator, 3, goes into 12 4 times, and the x's cancel, so I just have a 4 times 1, which is 4. And that is my new equation. Much simpler looking, much nicer. I've got an x to the first power, so I'm just going to add 6 to both sides. And I get 5x equals 10, divide by 5. And I get x equals 2. Sound good? All right, let's do a couple more in this video. Now I've got a binomial. So again, my LCD is going to include him as a single factor. So my LCD is going to be 8 times x minus 2. And I am going to multiply that whole thing by the original equation. X minus 2 cancels with the x minus 2 up here, so I'm left with 8 times 1 is 8. In this fraction, 8 cancels with the 8, and this x minus 2 is what I have to multiply that x by. So I'm going to end up distributing and getting x squared minus 2x. I want to solve. I've got an x squared term, so I need to subtract 8 from both sides. Now I need to look for factors. I can do the quick, easy, quick AC method. What multiplies to negative 8 and adds to negative 2? And that would be x minus 4, x plus 2. And I've got 2 answers, set each one equal to 0, and I get x is equal to 4, and x is equal to minus 2. We'll talk about checking these answers in another video, but we are ultimately going to end up checking them. All right, this last example on this video, LCD, are these 2 factors. And I'm going to, let me kind of get another color going here. I'm going to write them outside my original equation. You can put parentheses around them if you want. It helps you see what cancels easier. So this, of course, is all over the invisible 1. So when I multiply, this and this cancel, and the x plus 1 is what's left to multiply the 4 by. No denominator. It's gone. The x plus 1 cancels with the x plus 1, and I have 3 times x plus 2. So we have 4x plus 4, distribute carefully, equals 3x plus 6. Get your x's together. I'll subtract 3x from this side, and I get 1x, and I will subtract 4 and move him over there, and I get x is equal to positive 2. Okay, let's stop this video, and I'll come back on the next page on the next one. Bye.